Hi, everybody. Let's pick up on slide 30, and we're on the chapter 14 about climate change. Hopefully the next several slides will give you some good idea about some evidence that you can use when you're having conversations with folks and they're telling you that this is a hoax and climate change isn't real. Hopefully this will help with that. So we're going to go down through all these different things that we know are happening. We have good data, current information to show people that all of these things are real and that they're not only happening, but they're happening fast and they're happening every day. So let's jump into the first one and talk about actually temperature change. And so up in the right hand corner in the red numbers here, you see sort of a formula. And I recognize that almost all of the science information is done in scientific units, which is Celsius. And a lot of people here are not used to using Celsius, and so you don't exactly know what those numbers mean. So basically, 1 degree Celsius is about 33.8 degrees Fahrenheit. That's kind of a little bit a way that you can kind of do the conversion. So typically when I'm looking at Celsius temperatures, and that is the formula up there, so you can do conversion yourself. But typically room temperature, something that you and I would feel comfortable in, we wouldn't feel hot or cold, is going to be anywhere from 23, 25, 26, depending on if you like it warmer or colder. And so that's kind of like what room temperatures are in the 70s. So again, I'm just trying to give you a reference for when you see degrees C so you have a better idea what that is. And so the average surface temperatures, and so these are not ocean temperatures, these are just the surface temperatures. They've increased about 0.9 degrees C in the past 100 years, and most of that increase has actually happened since 1975. So to put that kind of time frame in context for you, I graduated high school in 1976. So most of this change has happened within my adult lifespan. Since 2000, we've experienced 13 of the 15 warmest years. And again, this data is a couple of years out of date. I believe we've had all of the every year is a record. And so for the past several years, every record has been broken. The northern hemisphere is particularly warm. Maybe you saw the news reports last year, last summer about Anchorage, Alaska hitting 90, and a large chunk of the northern hemisphere has gone up quite a bit. So again, this is data that can be measured. You don't have to argue with anybody. You can just pull that information out and show it to them. In the next 20 years, temperatures are expected to rise quite a bit. At the end of the 21st century, it'll be 1.8 to 4 degrees C higher than it is today. And so again, that's going to happen within your lifespan. We're going to have unusually hot days, and we're going to have heat waves. Some places in the world are going to have really long-lasting heat waves. The polar areas, as we've already seen this happening, are going to have the most intense warming. And put a big asterisk there next to that, because that's going to have big impacts for everybody. Even though not very many people live in the poles, their warming is going to affect us in a lot of ways. The surface temperatures of the oceans are also rising, and the warmer the water is, the more hurricanes and tropical storms that are going to not only be more frequent, but they're going to be more powerful, and they're going to last longer. We saw this last year in Bahamas. A huge tropical hurricane hit the Bahamas, and then it just sat there for hours and hours and hours. Actually, I think it just sat over the top of the Bermuda for over a day. And that is very unusual, that these big storms don't just move on like that. And so we have all kinds of first things happening now. If we look at the next graph, this shows you the temperatures again that are projected to happen. And again, you can see the red area up there, which is all of the North Pole, is expected to warm quite a bit. The actual precipitation patterns are changing also. Some regions are getting more rain and snow than they've had before, and others are actually getting less. In the United States, droughts have become much more frequent and severe. This can lead to agriculture being harmed. Sometimes the farmers can't actually get their crops in the ground, and then when they do, it stops raining and they dry up. This is promoting more soil erosion, which you guys know all about. It's also reducing water supply. So hopefully you watched the link I sent you last week about the Ogallala Aquifer. I know I said that incorrectly. And it can lead to more fires. And dry, more humid areas, then we get these heavy rains causing flooding that can kill people and destroy homes. It can cost billions of dollars in damage. There were 100-year record floods in 2008 that affected Iowa and the Midwest. We've seen a lot of flooding just in this past year as well. I know large areas of Tennessee and Texas had huge floods this past year. And again, all of this has cost, right? I don't know if anybody in our class has ever been through a major disaster. Maybe your home has had a fire, hopefully not, but if anybody's ever lost everything, what is the value of everything that you own, right? Insurance doesn't cover everything, and some people don't have insurance at all. So time and time again, just like with the crops not going through, there's an economic cost to all of this climate change. All of this bad weather, all of these storms, all of the farm fields that don't get to make a full harvest, that costs real money to a lot of people. And this sort of shows you how the precipitation's expected to change. Look at the tan areas, especially northern Africa and southern Africa, even parts of the United States and Central America and South America. All of these places are expected to have a decrease. If you look where Ohio is, sort of in the middle of the country there, we're sort of expected to, either have a 0 to a 10% increase. So it might get a little wetter here. I know the farmers locally have been talking about that the last several springs it's been cold and wet, and they haven't even been able to plant their crops until, almost May, and used to be that they would plant in April sometime. So the farmers kind of know, and they see things changing quite a bit. And these extreme storms and these extreme weather patterns, and I hate this term, the new normal, because all of it's about, lately the coronavirus is, quote, our new normal. But if we look at old weather patterns versus the way they work now, the upper picture is pretty much how the United States almost always worked. We would have warm weather coming in from the Pacific Ocean flowing across the United States, and that's sort of how our air currents work. In the last several years, in the last about 10 years or so, we've been having this crazy, weird loop pattern with the jet stream, and the bottom graph shows you that. So instead of the jet stream just coming in and kind of floating across the North America the way it used to, it's picking up that really cold air from North America, from Canada and the Arctic, and pushing it down, and then we kind of get stuck in this pattern like this. And that can lead again to, especially in the spring and the fall, some very extreme storms, both on the east and the west coast. And so the atmosphere is sort of being blocked by the changes in this weather patterns. And so some of these big storms will stall out and sit over an area and just pour down rain. Sometimes that's called like a rain bomb. And certain places have had that where it might rain 5 or 6 inches in less than a day. And to put the rainfall in context, everybody, we get about 30 inches of rain in Ohio, in our part of Ohio, per year. And that's out of the whole 12 months. So getting 5 or 6 inches in less than a day, that can absolutely cause flooding. And we have seen that in the news. One of the things I could really encourage you, and I did at the very beginning of this class, is to pay attention to the news. Even though everything is all about the coronavirus right now, there are quite a few things in the news about how the coronavirus and climate change, there's links there that can be made, and they're kind of interesting, actually. If we look at glaciers, so glaciers have been around since the last ice age. Some of these glaciers are thousands, tens of thousands of years old, and they're disappearing really quickly. Glacier National Park, which is here in the United States, when it was established about 75 years ago, had 150 glaciers within that park. And right now there's 25. I think there's still 25. And they are, quote, retreating. That's another way of saying melting. They are retreating very quickly. And you can see that in these upper pictures. That's the Jackson Glacier in 1911, and that's what it looks like in 2009. So most of that glacier is already melted. And for a lot of people in mountainous areas, this is where they get their summertime water. So precipitation isn't even across the calendar year like it is in Ohio. It's sort of sketchy here and there. And so people that live near glaciers have never had to do without fresh water because they can always get some from the glaciers melting. But if these glaciers are gone, then that could cause a lot of water deficiencies for them in the summer months, including some of the places in California. So the tops of some of those mountains, get snow and ice pack. That's not the same as a glacier, but it still melts, and they can get the ice melt to use for fresh water in the summer. And if the weather patterns change and they don't get as much ice and snow, then that's going to impact their water as well. So if anybody has never seen a glacier, you need to get there to see glaciers soon, because they are melting at a really, really quick rate, a scary fast rate, actually. So what about polar bears? So there's a YouTube link there, which I think you can go back to this lecture and you can click on. And there's a nice YouTube video kind of explaining what's happening with the polar bears. So let's think about where the polar bears live and how they live. And this is kind of an iconic image here. So polar bears are in the Arctic. They're in Greenland. They're across some of the areas near the Arctic Ocean. And they are able to be there. They're a top carnivore, right? So that means that they need to have a lot of food to eat. And there's really not that much food in the Arctic because of the really low net primary productivity. But because of the ocean ice, they can go out hunting, and they can harvest typically sea lions, and I know it's sad to think about seals being eaten, but they can get other animals from the ocean, and that's their food. And so during the winter months when the sea ice is there, they go out and go fishing and hunting from the sea ice. But when the sea ice is melted or it doesn't form very much, their hunting platform is really limited. And even though they're amazing swimmers, they can't go swimming hundreds of miles out to the open ocean to try to catch a seal. So I know you've heard that polar bears are having a really hard time right now, and they are. As climate change is changing the Arctic, less and less sea ice is forming, and so they just are not able to hunt as much as they used to, a few decades ago. And so it's true, some polar bears coming in from the winter, that's usually when they would be at their heaviest weight, and they would be, eating high fat sea lions and occasionally a walrus or something. And they would be at their heaviest weight coming off the sea ice in the spring. And they're coming inland now off the sea ice, and there are skin and bones. You know how thin a polar bear must be if you can actually see its bones through its fur. And then they're coming on land, and there really is not very much there for them to eat. They are starting to come, and they've always, been a top predator, and they certainly cannot, people encountering a polar bear, if you do not have a pretty fearsome weapon, you're going to be food. And so polar bears are coming inland, and they're going and they're raiding people's homes. And there was a picture of a whole bunch of polar bears that came into a town in Greenland, and they were all walking up and down and going through the school, basically, I think, looking for somebody to eat. And so this is a terrible time for them. They are not doing well as a whole, and a lot of people think that in the next 20 years we're going to just completely lose polar bears in the wild. Now, maybe that makes you sad. Maybe you don't care, because after all, they're polar bears and they don't live here. And, does it really matter to you whether they exist in the wild or not? For a lot of people, yes. They want, they feel like empathy for polar bears, and they understand that what's happening to their homes is a direct consequence of climate change. On the right picture, you see the face of a glacier doing something called calving. And so huge chunks of glacier are coming off all the time like that. And you know how old the ice is based on the color. And so some of these older, very, very old glaciers are this deep, interesting blue color. And we're losing large chunks of them all the time. Not only individual glaciers, but whole ice sheets, like the Greenland ice sheet is melting and receding really, really fast. And again, what are you looking at there? You're looking at fresh water that is collapsing into the ocean. And so that fresh water that's all frozen there and has been frozen for millions of years or tens of thousands of years is falling apart and is becoming part of the ocean. And so, again, we don't have that much fresh water. That's why we talked about water before we did this chapter, for you to remember how very little bit of fresh water we actually have compared to ocean water. And so there's a very good video here about how Greenland's ice sheet is melting, and how do they determine what's happening there. And so please, 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 with all these videos, just take a few minutes. Most of them are pretty short, and click on those and watch them. I cannot show them to you when I send this to you by a YouTube. You can't show a YouTube within a YouTube. So please watch that, because it's really interesting to see how they measure that flow. So the warmer water that is, the oceans themselves are actually becoming warmer. That is causing Antarctica's ice shelves to break apart and melt. And some of these that come apart are huge. Like one a couple years ago that broke off was the size of the state of Delaware. So they can be enormous. And once they flow out to the ocean, then that begins the melting process once they're not attached anymore. And so the actual amount of the snow on the interior of Antarctica, that's increasing there because there's more precipitation. and that has a lot to do with the way the ice shelves are melting. That sounds like it wouldn't be a big deal, but who lives in Antarctica, right? We have special animals there called penguins, and they are not adapted to having to deal with multiple feet of snow. And so this is impacting them. And sometimes when those big ice sheets break off as well, then their normal migration patterns where they get from the ocean to their breeding habitat, those are being blocked off. So this is being very hard on some of the penguin populations too. So there's a new, what we talked about albedo before, but this is a reminder, okay? So these ice sheets, when they break off, they expose darker surfaces, whether it's the open ocean, which, you know, the water itself is pretty dark, or whether it's land. The land is also much darker than ice is. And so that causes this positive feedback loop to happen. And so those darker surfaces now absorb more of the sun's heat, and that causes even more and more melting. So this is, some people consider this to be like a runaway system that's happening now. And unless something pretty much dramatically changes really soon within your lifespan, I don't know that we'll be able to save any of this ice. So it melting is a huge problem. So as that ice melts, there's a lot of things happening. One is that is sort of opened a new shipping lane up in the Arctic Circle. And so before, countries from Asia to North America would have to go the long way around. Well, now as this ice is melting, there's more and more of these open channels that are forming. And so you guys go look there. There's a picture from 2016 of the very first cruise ship that actually cruised across the top of the world through the Arctic Circle. And so this may then make new areas available for mineral exploration and new shipping ways. This may become a problem for the United States and Canada because Russia wants to lay claim to a lot of that territory because it's attached to them. So let's talk about something very important with the Arctic soils. And I know most of you have not been there and you don't really understand how that soil is different, but it is very different. So in the Arctic, because that it's always been cold, that soil is considered to be permanently frozen, and that's called permafrost. And basically the soil is not so much soil as it is a bunch of dead organic matter that has accumulated for thousands of years, and the decomposition process there is really slow. And so every spring and summer when the plants are growing, they grow and then they go dormant, and some of them die. Those leaves and pieces of those plants and the animals too, for that matter, they just sit there and they become eventually part of this permafrost. And as long as everything has stayed cold, that's worked pretty well for that whole system up there for thousands of years. But now as it's warming up, the permafrost is starting to melt. And as it thaws, that's causing problems. And you can see in the bottom couple pictures, that's what a roadway looks like in Alaska. They probably shouldn't have made it out of blacktop in the first place because of the color of it. But anyway, you can see the road is just all buckled and moved, and that's because the permafrost is sinking. It's caused buildings to actually sink into the ground as the permafrost does. And then some of that old material that is starting to decompose really quickly is releasing a huge amount of methane. So if you look at this picture over here on the right, that low-lying area is sitting there bubbling out methane. And if you go back and look at a few slides ago about the different kinds of greenhouse gases, methane is exceedingly potent. And there's a real big worry here about how much greenhouse gas, including carbon dioxide and methane, is actually trapped in the Arctic. And if all of this permafrost melts really quickly, all of those greenhouse gases could be released like very fast. And that would accelerate climate change even faster than any of the models. So one of the problems about some of the earlier climate change models is they didn't factor in all of this permafrost melting. They never even considered that the permafrost might get warm enough to melt. And then nobody ever went out and actually started measuring to see, well, what happens when the permafrost decomposes, what kind of gases are given off. And that research has been actively going on for the last 5 years or so. And so some of the newer greenhouse climate models that have been put out include this information for the first time. And that's all of a sudden when the climate change forecast from 50 years changed to like 10 to 20 years. That big jump was in a large way because of this permafrost melting. And so you guys keep that in mind. That's a really important point. And you know, a lot of people did not really consider that until more recently. So the actual idea about sea levels rising, and if anybody's like home and like binge watching anything, why don't you guys watch Waterworld? It's a really old movie that Kevin Costner was in a long time ago, and it kind of went, you know, the premise was that the ice caps had melted and flooded the world, and so the world was now a quote water world. So it was kind of an entertaining movie, but why don't you watch that if you have any time and think about it. But what's going to happen with the oceans, okay? So there's a couple of things about the sea level rising. Why is this going to really happen? And how do we know it's going to happen? Okay, so one is the extra fresh water that's currently tied up into these glaciers and these ice sheets. That's going to melt, and that itself is going to cause sea level to rise. The other thing that's going to happen is when water gets warmer, the water molecules, the water itself expands. And so it's both quantity of water, so the oceans are going to have more ocean water in them from that melted ice, and the warmer they get, the more they expand. And so that can cause a lot of beach erosion. It can cause coastal flooding, and I'm going to show you, hopefully be able to show you a video about that in a minute. And it can cause salt water to get into aquifers. Any of the aquifers that are near the low-lying places, like in Florida and some of the other places you can see here around the United States. And this is worldwide. It's not going to just affect the United States. And then lastly, storm surges. So we have a higher ocean, we have a warmer ocean, and look at some of the edges where the storm is expected to rise. Most of these arrows are in the blue colors, and they're telling you that the sea level can rise between 3 and 6 inches, that's in millimeters per year. And then some of the low-lying areas, like in Louisiana, 9 to 12 millimeters per year. So again, this is all real, and anybody who lives along the coastline or watches the news can see that happening. And so the next figure, and I think I can show this to you in here. Oh no, it is a YouTube video. Shoot. Okay, I want you guys to for sure watch this one. This shows, like, if you can look at this, where is Florida at, right? So this will show you not only for the United States, but it'll show you worldwide what is predicted to happen as the sea levels rise. So you can see here that most of Florida and Virginia and South Carolina is gone, right? It's under the water now. And sea levels have already risen between 4 and 8 inches in the last century. There's actually a small town in Alaska that's totally underwater now. It used to be a gold mining, silver mining town, and the sea levels have risen enough that that town is now underwater. So again, please click on this video and watch it. It's really interesting to see how all that's going to play out. And you can kind of see, you know, here in Ohio, our climate's obviously going to change quite a bit when the ocean is this close to us. So, and then where's all those people going to go? You know, where are all the animals and the plants and the ecosystems? What happens to all of those? So, again, please watch that and think about it a little bit. So I mentioned to you about the storm surges, and again, sometimes that's going to be just real localized, and it happens when there's a high tide event and a storm, and both of those together then cause a huge storm, like what happened in Hurricane Sandy. A lot of cities are going to be flooded, and in the United States, about 53%, more than half of the people live in coastal areas. And so their cities, their belongings, their homes are really at risk. The vulnerability to storm surges are going to increase. And a lot of that has to do with the wetlands being removed. Wetlands are really great at absorbing extra storm surges, but when the wetlands are not there anymore, then the water can just come on in. The dams that we've created all over the world, those stop sediments from replenishing the deltas, and the deltas are a form of a wetland. And so that's another reason why wetlands are disappearing. In 2013, there was a huge typhoon, and a typhoon, you guys, is just a hurricane that happens in the southern hemisphere. When they happen in the northern hemisphere, we usually call them a hurricane. And that hit the Philippines, and 7,000 people died. There was over $1.5 billion in damage. When was the Puerto Rican hurricane? Was that 3 years ago now? I think that's when that one happened. So these things are active right now, and they're happening every day. I mentioned already that a lot of people live near these coastal areas. And so certain countries are working really hard at investing in new technology. They're adding seawalls. They're adding storm surge gate protections. They're doing all kinds of things to try to mitigate the damage that's going to happen. You know, and there's a lot of places that are going to experience this and have already experienced it. Some of the Pacific Island countries will have to be evacuated. The people just can't live there. Well, they won't be able to live there because their country's going to be underwater. Here are a few pictures of Hurricane Sandy's superstorm, and again, I'm not sure that you guys will remember that, but maybe you will. But this was one of those events that happened because the storm happened to hit at high tide. And so I think it was a high tide at a full moon, and that caused the storm surge to be absolutely enormous. And it totally, you know, destroyed lots of areas within New York City, and including where the 9/11 memorial is. that whole area ended up becoming underwater. So again, this is happening now. And every time we have one of these events, it costs so much money. It's millions or billions of dollars in damage, right? Plus the suffering that people have to go through when they lose loved ones or they lose their property or their homes. It's really sad. So there's this country called Tuvalu, which is a small Pacific island country, and they've been losing their land over and over again every year because of sea level rise. And so they were getting fairly desperate, and they asked the world for help with this. And luckily, New Zealand accepted them. And so they became the first environmental refugees, and about 11,000 people left that area in 2003. And so here's a good question for you guys. Do you think the rest of the world should grant such environmental refugee status, and that we should all accept these people in? Are we responsible for taking care of them? So you know the United States has a pretty negative view of refugees, but are environmental refugees different? Should all the countries have a policy about allowing environmental refugees to be able to move to anywhere that they want to move? Should other countries, are you willing to pay to have people relocated? I think this is a big concern. Certainly the people that live there in Tuvalu did not cause climate change. You and I and all the developed countries caused them to lose their country. So who should have to pay for that? Or do we just say too bad, too sad, and go live on a boat? What is supposed to happen to all of these people? And again, this was just 11,000 people, but it's going to be millions of people that this is going to happen to, and they have to go somewhere, right? Or do they? I mentioned to you on Monday about how the oceans absorb CO2. They're really, really good at doing that. And the problem is that that extra carbon dioxide that's dissolving in the water is changing the pH of the water. And organisms can't really deal with a change in the pH. Some of them can't build their seashells now. They used to be, there used to be lots and lots and lots of organisms that use that extra carbonate that was in the water to do that with, and they're having a hard time. Some of the pH is expected to kill most of the coral reefs. And that, again, depends on how much more carbon dioxide is going to dissolve in that water. Right, already the pH has decreased by a 0.1 pH unit. And remember, that is a logarithmic scale. So that a 0.1 on a log scale is a huge amount, and it's already changed. We expect that a change between 0.15 up to 3.35, that will kill almost all the coral reefs not in the United States, but in the world. And so the coral reefs are incredibly important for ecosystems. That's where an awful lot of the food that we eat from the oceans, they use the coral reefs for part of their life cycle. People like to go to coral reefs and go scuba diving and snorkeling. The coral heads also protect the coastlines. And so losing the coral reefs, that could then lead to more storm surges. The warmer water also is a factor for coral. Coral is very sensitive to any kind of changes at all. And occasionally when we have a change in the jet stream and we get an El Nino event, and it makes the water warmer, the coral will die. And so there's what coral looks like on the left when it's healthy. And when it dies, it just becomes this white bleached stuff that's there on the right. Usually moss, some kind of underwater algae will take it over and colonize it, but it's not a living coral anymore. This is kind of a depressing lecture. At least it is for me to think that all this is happening. So as far as the organisms that we've talked about, a lot of organisms are will most likely go extinct. We've talked about that we're on a mass extinction event now, and that's because organisms are adapted to their environments. And as all of the climate changes, all of the things that are tied into weather, like migration, breeding patterns, pollinator activity, all of it is going to change. Some species will migrate. Some species are able to migrate if they have some place to migrate to. A lot of those species that live, especially in cold areas or maybe on the tops of mountains, they don't have anywhere left to go to. And so some of those species will be going extinct because there's no place else once they get to the top of the mountain. Where are they supposed to go now? Rare species that are all in all these preserves that we talked about, if something happens to that preserve or if people need to use that land, then those species can go extinct too. Now, something that's been debated by botanists for a long time is, well, all this extra carbon dioxide that's in the air, won't that make plants grow better? And the plants could fix this for us, right? Because the more CO2 that's available, the more photosynthesis that will happen, and they'll be able to clear the air for us. So technically that is true, but there's a couple of other things that impact their ability to do that. One is the changing weather patterns. If all of these droughts and fires and diseases that are expected to happen with changing climate actually happen, then there's going to be less plant communities. And the less plants we have, then this whole thing kind of falls apart where, well, the plants will just take care of it for us. So this could be true. We could actually plant our way out of this mess. It would take a worldwide, global, concerted effort, and we would have to reforest all the forested areas, including Ohio. So if we start reforesting our agricultural areas, then where are we going to grow food? So I don't think that this is really a very realistic plan. It might help us out in the short term, which is why typically, except for this spring, typically every spring I work with groups and I plant about 1,000 trees. And I've done that for most of my adult life. But this spring that's not going to happen because of coronavirus and keeping away. I think so far I've only gotten a couple hundred planted. So this could definitely work for us, but it'll only work if we have places for those plants to grow. Again, we've already seen different animals moving and changing where they live. This is a little purple house finch. You might have seen this finch. To me, they don't look purple. They look reddish. They're not as red as a cardinal, but they're kind of reddish. They have changed their winter range. They've actually moved north in the last 40 years. So the lower dot there, I think that's looks like Missouri. They've moved north up into Wisconsin. That's where they're wintering at now. The little animal down at the bottom, which is called a pika. And by the way, you guys, that's a rabbit. That's a member of the rabbit family. And it's the only member of the rabbit family that has like those little teeny tiny ears like that. But pikas live in mountainous regions. They are adapted to the cold. They go out during the spring and summer and collect seeds and flowers, and they sort of have pantries underneath and in between the rocks. And then when the snow hits, they just stay underground throughout the winter and eat what they've collected. And they are actually disappearing because as they get higher and higher and higher, there's less places for them to actually be able to burrow. So the tops of some of these mountains are just too rocky. They can't dig burrows there. And there's very little plant life up there as well. So some of these organisms are actually going to be extinct, unfortunately, probably in your lifetime, or they're going to have to move. In agriculture, farmers have already been talking and seeing what's been happening with production. So some of the growing seasons have been getting shorter. They've been having longer droughts, and that's resulted in less food production. And we know about human populations. We've already talked about how many people there's going to be. And so populations are increasing, and it's becoming more and more difficult to figure out how to farm. In forestry, we started out this whole class by talking about the extreme fires that have been happening in California. And we don't have to go, I mean, we can go to California if we want to, but something that happened this past fall that you were probably more aware of, there were those huge fire events happening in Brazil, and there were huge fire events happening all across Australia as well. So those increased fires have been caused in part by insect and disease outbreaks within the forests, and invasive species moving into the forests, and that's why we're having so much fire damage lately. And again, every tree that gets removed, that means that that tree can no longer pull in CO2 for us. And you know, to make matters worse, then, as all these plants are burning up in these fires, tremendous amounts of CO2 are being released at the same time. So all these forest fires are kind of a double hit as far as climate change goes. This map was produced by the Forest Service a few years ago, and again, this shows what's supposed to happen with the kind of vegetation that we have now versus with climate change, what's expected to happen. And again, you can kind of focus in there on Ohio. It's a good example. We have all of these different forest types here, including maple, beech, and birch. That's the red area. And look in Ohio from 2070 on. That is not going to be a vegetation type anymore. So, and not only are those trees not going to become dominant anymore, stay dominant anymore, they're going to be replaced. And then all of the organisms that depended on those particular types of trees, and there are many, some insects, some birds only are associated with certain trees. Some of these trees, like the oaks, are really good at producing nuts or acorns for animals. So in some areas, those plants will be expanding. In other areas, a lot of the maple and the beech and the birch will just be gone. And so that's going to cause whole ranges to shift very quickly. What about people? So again, besides what's happening right now with the coronavirus, people are going to actually die of heat-related deaths. And that seems very hard for us to fathom, but in a lot of very developed cities and countries, people live in huge high rises, and if something happens, there's a prolonged heat period of time, and they're not able to access air conditioning. Most of those places can't even open windows. In very, very poor countries, people don't even have air conditioning. And this can absolutely cause heat-related deaths. A few years ago, there was a disease called Zika that was on everybody's mind. Zika was was a tropical disease that was spreading northward, and it was causing fetuses' brains to form improperly while the mom was carrying them. So if the mom got bit by an infected mosquito, she would give birth then to a baby who, in some cases, their brain hadn't developed at all, or it was not well developed, and the child was born with all kinds of handicaps and problems. There are a lot more ticks in our area than have ever been before, and some of those ticks carry Lyme disease and other diseases that we're just learning more about. And by the way, everybody, dogs can get Lyme disease. And so we go down to Kentucky a lot, and that's a big problem there for not only people who are out and about and get bit by ticks, but it's also a big problem for dogs. And so that will be spreading northward as things warm up too. Air quality is getting worse and expected to get much worse because a week or so ago, President Trump repealed some of the Clean Air Acts that were in place for a number of years. And so as air quality gets increasingly poor, people develop all kinds of problems, right? Emphysema, asthma, and all kinds of things associated with that. Every time there's one of these big major floodings, then there are lots of waterborne diseases, usually associated with sewers and water treatment facilities flooding, and then all of that stuff gets in, all that sewage gets into the water and can cause diseases too. So this is, if we have this graph represents if we have lower emissions and we actually do something about air quality, where sort of is expected to happen over time. And the red areas are if we continue with higher emissions. And so I think that's kind of interesting. It's sort of showing these different states and what will it be like in other places over time as a result of just the climate on human beings. How is that going to affect you? We haven't even talked about people drowning in these floods, but again, that's something left to happen. And again, the impacts are going to really vary by region. Where we live is going to kind of tell us how we are going to experience climate change. The Arctic so far has really had the most dramatic changes in climate change. And there's a polar bear off on a small piece of sea ice floating somewhere. The building on the right-hand side is a building that has collapsed because of the permafrost. The graph at the bottom shows how much sea ice there used to be and how much sea ice there is now. On the video that I wanted you guys to watch earlier, you'll see that happening as well. So again, I think you guys like to watch the videos, even if some of them are sad. So I would try to get you to watch as many of those links as you can. You just have to go back to the Canvas lecture, chapter 14, and kind of scroll through them, and they're all indicated by a blue link, and you can start at the beginning as you do your study guides and watch those. So again, there's a climate change assessment, and these are the data from 2014. I mentioned to you that the newest one came out in 2019, but I don't have that report to share with you. This is what the 2014 report was projecting, and all of these things have happened. So nothing new. I'm sure the 2019 report is similar. You know, they didn't put a lot of numbers here. They just said this is going to get worse, and we're going to have problems with this and problems with that. And so I think all of this information would still be true. The difference is how fast it's happening. And again, a lot of people are predicting 10 to 20 years until all of these things come true, which is not very long time to get moving on this, right? This is predictions from two very different climate models. The one on the left is if we were actually able to pass something and make it happen, and we were to all reduce climate change. That's the picture on the left. The picture on the right shows you the projected temperature change, and again, this is in Fahrenheit, which I like that this graph finally is in Fahrenheit so you understand. So on average, by the end of the century, Ohio will be between 9 and 10 degrees on average hotter than it is now. And so again, it's different areas are going to be affected in different ways. The most northern areas, look at poor Alaska there. It's going to be heavily impacted, right? Some parts of Alaska are expected to have a 15-degree temperature rise, and so that's what's expected to happen. For this figure, and we only have a couple more slides for today's lecture. For this figure, I want you to pay attention to it. You can pick an area. Maybe you don't want to live in Ohio anymore after you graduate Miami. You want to go somewhere else. Why don't you read about what that other area is expected to happen? Maybe your parents or whatever climate change denier that you know, maybe their goal is to go live in Florida. Well, why don't you read what's going to happen there in Florida so they can be more, so you can help educate them on things that are supposed to happen. So again, different regions are going to experience climate change in lots of different ways. And I think that's important. Not everything's going to happen everywhere at the same time, right? And so it really makes a difference on where people are. This graph shows, or this figure shows, places that are expected to get drier in the United States and places that are expected to get wetter. So you can see our little neck of the woods in Ohio, we're expected to have less droughts, so it's expected to be wetter here. That could be good or bad, depending on what kind of crops that you're trying to grow and at what time. Okay. So the last couple of slides I have here are about what don't we know. And so I picked this sun image for this, and hopefully you guys know enough about how the sun works that you see up in the right-hand corner, there's a huge solar flare there that's happening. And so that's one of the big things that we can't factor into computer models. We don't really know, is the sun going to get warmer? Is it going to get cooler? Are we going to stay on the same rotation that we have now? or is the axis that we're at 23.5 now, is that going to change and we're going to be moving further away from the sun? How many solar flares are going to hit the Earth from next year, right? We don't know this stuff. And so it's not been factored into the climate models, which might make them completely wrong. We're only going by what we have right now. Some of the other uncertainties are about the albedo effect, which I've already mentioned to you. How fast and how much sea ice there is, that's going to help slow down climate change. But as the sea ice melts, more and more of the open water or the land is being then exposed, and that absorbs heat. So that makes, this is that positive feedback loop that we talked about a while ago. And that really is not very well to be modeled in most of the climate models. So we're just collecting data in the past 10 years about the albedo effect. And so some of the climate models are getting better and better about that. And the last one was about the tundra decomposition that I already mentioned to you. Again, that really wasn't considered until very recently. And as that permafrost melts, then tons and tons and tons of greenhouse gases are being released. And that stuff has been tied up in that organic matter for millions of years, just waiting to decompose. And so if all of that stuff decomposes really, 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 really fast, then that could totally accelerate the climate model. And maybe you don't have 10 to 20 years. Maybe you have 5 years. Again, these are all uncertainties that make some of the computer models very inaccurate. Some of the computer models are more accurate than others, but all of them pretty much agree with what's actually happening. So let's quit there for today. This sort of shows, a polar bear clinging to a little piece of ice. And we'll talk about the tipping point next week when we can talk about this together. And I'd really like to have some discussions instead of me just yammering at you online. So let's finish up the climate change chapter on Monday. And you'll be ready to have a quiz then on Monday about the climate change chapter. And then it'll be time for you to have another exam. So, all right, that's it for today. And I'll send this out so you guys can watch it for class for tomorrow. Okay, you guys have a good weekend.